This is the PowerPoint about rocks and the rock cycle. Characteristics of a rock. A rock has to be solid. It's not going to be a liquid or a gas. It has to be formed in nature. You can't manufacture a rock. It's usually a mixture of minerals. Like we've been talking about minerals. Once we've talked about crystals, we talked about atoms, crystal structure. Crystals build minerals. Minerals build rocks. So we're sort of following a progression. Atoms to crystals to minerals to rocks. Rocks can have organic matter. They don't have to have them though, but they can have organic matter. And then identification is based on mineral content and texture. When I took my mineralogy class in college, I had to look at a rock and be able to identify all the different minerals that were in that rock and then come up with the name of the rock. Luckily, you guys don't have to get that in depth, but that's how we actually identify rocks, based upon the minerals that they have in them. There are 3 different rock types. The first rock type is called igneous. It's formed from cooling and hardening of magma or lava. Remember, magma's inside the earth, lava is when it comes outside of the earth. And the key thing here to remember is that igneous rocks are formed from cooling and hardening of that really hot magma or lava. There are 2 types of igneous rocks. You're going to need to know both and what they mean. The first type is extrusive. Extrusive, think about the word exit. Extrusive is formed from lava, which is outside of the earth. If you exit the earth, you'd be lava. You're outside of the earth. And extrusive igneous rocks are going to have a fine or glassy texture. Small crystals because they're going to cool very quickly because it's so cool outside. Some examples of igneous extrusive rocks are obsidian, pumice, and basalt. Pumice is the stuff that maybe your mom or yourself scrub your feet with, get off all the hard spots. It's that light color, got lots of holes in it. Igneous intrusive rocks are formed from magma. Magma's inside of the earth. Intrusive igneous inside of the earth. And then again, remember, magma's inside the earth. And it's going to have a coarse texture and large crystals because the temperature is warmer inside of the earth. So it's able to cool slower so that the crystals can grow bigger. And an example is going to be granite. You'll see that in class. The second type of rock is sedimentary rock. It's formed from compaction and cementation of sediments, usually in water. Doesn't have to be in water though, but sedimentary rocks, sediments. If you think about sand, mud, clay, those are all sediments, and a lot of the times those are going to be in water. And there are 2 types of sedimentary rocks. Clastic rocks, kind of sounds like plastic, but it's got a C. Clastic rocks are made up of bits and pieces of rock and organic matter. Clastic rocks, if you think about the word clast, it means a piece of a rock. So clastic rocks, you're going to see the little bits and pieces all stuck together in one big rock. And an example is conglomerate. That's actually made of little pebbles all stuck together in one big rock. Sandstone has little individual sand grains stuck together into one big rock. And then shale is made sort of similarly to sandstone. You've got little grains that get stuck together in one big rock. Non-clastic sedimentary rocks are made from minerals dissolved in water, which is the chemical non-clastic sedimentary type rock, or made up of once living things, or meaning organic. Once living things is made of organic stuff. And then the example would be limestone. Limestone has crushed up little pieces of calcite. which could come from bones or shells decomposing. Gypsum and rock salt. Rock salt's what's in the ice cream. Metamorphic rocks, that's the third and last type of rocks. The definition is that it's formed when existing rocks are changed by heat, pressure, or chemical action. So the big thing there are heat and pressure. If I say to you a rock formed by heat and pressure, you better be able to tell me that's a metamorphic rock. If I ask you how a metamorphic rock is formed, you ought to be able to tell me heat and pressure. And then the big thing there is that you can't get a metamorphic rock unless it's coming from and being changed from an igneous and a sedimentary rock. The two types of metamorphic rocks. Foliated, meaning like folds, layers. You've got different minerals and different bands or layers. Gneiss is this word right here. That's the way you pronounce it. Gneiss. Gneiss is nicely banded is the way to remember that. If you see rocks with a whole bunch of different layers, they're either sedimentary rocks that have been metamorphosed into metamorphosis. Remember, if you think about a metamorphosis, that's a change. So these rocks are being changed into a metamorphic rock. Non-foliated means there are no visible layers, like in marble. Marble is the metamorphosed limestone. So you start out with limestone, and then you heat and pressurize that limestone, and it can turn into marble. And then some different things about coal. Generally, coal is going to be from sedimentary rock, although it can be from metamorphic rock. And there's some different types of coal. You've got peat, which is made from organic material that isn't yet a rock. Lignite is the soft, low heat output, fast burning coal. Bituminous coal is the most abundant type of coal, and that's actually a Virginia resource. You found it out in the Appalachian Plateau, way out on the western part of the state. And then anthracite, hard, high heat output, slow burning. And then in your notes it says copy the coal formation table here. So here's that. The things that are not yet a rock, you've got organic matter, and this organic matter breaks down into what we call peat. If you've ever heard of a thing called a peat bog, it's kind of like a swamp. And then as that peat changes, it becomes lignite, and then you can have bituminous coal, and then you can have anthracite coal. And the way to sort of remember that, anthracite is going to get an A for being the cleanest burning coal. Bituminous coal gets a B for being the second best burning coal. And then lignite is the worst type of coal to burn. It puts off the most pollution, basically. The processes that form rocks. This is going to be important to fill in all those boxes at the bottom of your notes for the rock cycle. Melting. Think about anything that has to do with melting. Ice cream melts. Weathering. The breaking down of rock by physical and chemical means. Compaction and cementation. If you squash something together and then stick it together, that's what we're talking about here. Cooling and hardening. Cool something down, it's going to harden up. Like if you think about burning a candle, when you blow out that candle, that wax starts to cool and then it hardens. And then heat and pressure. You ought to be able, you have a little light bulb going off right now that's saying to you, metamorphic rock, heat and pressure, metamorphic rock. The rock cycle is a continuous process in which rocks change from one type to another. The big thing here is it is a cycle. It occurs over and over and over again, over thousands and thousands of years. It never stops, and it doesn't really ever start. It just kind of is, and it goes and it goes and it goes. So on your page, you have all these empty boxes. And what you need to do is find that very middle box on your notes and write in the word metamorphic. At the very top left box, you're going to fill in the word igneous. The very bottom right box, you're going to fill in the word sedimentary. Now, if we have an igneous rock, we're going to change that igneous rock. We're going to weather that igneous rock, and we're going to break down the igneous rock into sediments. And once we have those sediments, we're going to make a sedimentary rock out of sediments. Make sure you can put that together. You got sediments, you're going to be making a sedimentary rock. And in order to make that sedimentary rock, you're going to need to compact and cement those sediments together into that sedimentary rock. Once you've got that sedimentary rock, you can then melt that sedimentary rock. Be real careful with your placement of these words along the way. Make sure that you've got compaction and cementation on the outside of your notes. You should still have a big blank right in this space here. For this word here, melting, I think that's the only one you got a place for. And then once you've melted that sedimentary rock, it's going to become magma. Once you have that magma, you can then make an igneous rock by cooling and hardening that magma. Make sure you're filling in on the inside. You should still have a blank in this space over here. Make sure you still have a blank. Once you've cooled and hardened that magma, you've got an igneous rock. If we go back to sedimentary and we want to make sediments, we're going to weather that sedimentary rock in order to get sediments. If we have a metamorphic rock and we want to get sediments, hopefully you're able to tell me that you're going to weather that metamorphic rock. Make sure you're filling in the box that points from metamorphic to sediments with the word weathering. If we want to have an igneous rock and we want to turn that igneous rock into magma, we're going to melt it because magma is hot. Once we have our magma, we can, well, if we start back at a metamorphic rock, we're going to change that metamorphic rock into magma. Hopefully you're telling me in order to get magma, we've got to melt something. And make sure you're filling in the correct box that goes from metamorphic to magma. In order to get your melting, or in order to get your magma rather, you always have to melt something. If you're going to magma, you're melting. If you're coming from an igneous rock to a metamorphic rock, you ought to be able to tell me heat and pressure. You have to have both heat and pressure in order to change that into a metamorphic rock. If you have a sedimentary rock and you're changing it to a metamorphic rock, you're going to be using heat and pressure. So let's think about this for a minute. If we need magma, you're going to melt something. Whatever you're doing, you're melting in order to get to magma. If you're trying to get to sediments, you're going to weather in order to get to sediments. If you're trying to get to a sedimentary rock, you have to compact and cement those sediments. If you're getting to a metamorphic rock, you have to use heat and pressure from either an igneous or a sedimentary rock. I talked about that before. The only way to get a metamorphic rock is to heat up and pressurize an existing rock, which would be either an igneous or a sedimentary rock. If you want an igneous rock, the only way you can get there is by cooling and hardening magma or lava. Could be the same thing.